So exciting as this may be, we're back to mass versus weight. This is part 2 of the lecture. If you remember, mass is the amount of matter in an object. And weight is gravity's pull on an object. Okay, let's consider the moon versus Earth. That's his moon. Okay, the gravity on the moon is 1/6 the gravity on Earth. Okay, so if the gravity on Earth is 1, gravity's pull on the moon is 1/6 of that. So if something weighs 20 pounds on the moon, or 120 pounds on Earth, there is 1/6 the pull on that, so we would divide 120 by 6, and we would get 20 pounds. Whoops, this should say pounds. 20 pounds on the moon. The weight has changed. The weight has changed, but the mass has not. The mass is still the same. So if we're talking about gravity's pull and the mass being the same, obviously gravity has some connection. Gravity gives us the connection between mass and weight, and it is simply this, that weight, W-E-I-G-H-T, is equal to the mass times the pull of gravity. Or W equals mass times G. On Earth, G is equal to, rounding it off a little bit, 10 meters per second squared. Okay, so that's a number you are going to want to know. So if we have 1 kilogram of mass, we are going to multiply that by 10 meters per second squared. And we are going to get 10 newtons, newtons of weight. A newton is a kilogram meter per second squared. Don't worry about that. But you do need to know this equation for converting the two. Okay, let's look at some other conversions. I'm going to do an English to metric conversion first, and then we'll convert the mass we come up with in kilograms to newtons. So, okay, one thing you need to remember is mass. The units are going to be in kilograms. And if you're looking at weight, other way around. No, that's right. Weight your units are in newtons. So suppose I want to convert, let me move this up a little bit, 60 pounds to A, kilograms, and then B, newtons. So the first thing I want to do is take 60 pounds. This is for A. I happen to know that 1 kilogram weighs 2.2 pounds. 2.2 pounds. What I've done here is I've made a conversion factor. I've taken two things that are equal, put one above the other so I can cancel the units. We'll work on conversion factors a little bit more later, but what happens is if I multiply 60 times 1 and divide by 2.2, the units of pounds will cancel, and I am left with 27.3 kilograms. Now, I'm not able to convert pounds easily to newtons, but I am able to convert kilograms to newtons. Okay, so I know that if I take 27.3 kilograms, my mass, and I multiply that by g, gravity's acceleration, which is 10 newtons per kilogram. Kilograms will cancel, and I have 273 newtons as my weight. And again, the weight is 10 times the mass.